All right, let's try some practice. So let's simplify this. N times n plus 1 factorial is just n plus 1 times n factorial divided by n factorial. N factorial and n factorial will cancel, and I'll be left with n times n plus 1. And that's my simplified answer. Let's try another one. N factorial here is the same thing as n times n minus 1 factorial. And I did that because I noticed here is also an n minus 1 factorial. So minus n minus 1 factorial divided by n plus 1 factorial. Okay, so n minus 1 and n minus 1 I can undistribute and get n minus 1 factorial times n minus 1 because I'm left with a 1 right here and an n right here. Okay, and then this is all divided by n plus 1 factorial. Now this bottom part, I'm going to undo 2 times to get it all the way to n minus 1 factorial. So that gives me, on the top, n minus 1 times n factorial, n minus 1 factorial times n minus 1 divided by n plus 1 times n minus 1 factorial. Now these will cancel, and I'll be left with just n minus 1 over n times n plus 1. And I've eliminated factorial, so I'm done. Alright, let's try a permutation combination example. So the question is, in how many ways can the letters in the word candle be arranged? So first question, does order matter? In this case, yes, because we're talking about a word, and the order of the letters will change the word, so order here does matter. Number two, how many options are there and how many things are being chosen? Well, we've got 6 letters, and we're just rearranging them, so we've got 6 spots. So n is going to equal 6, and we're choosing r. R equals 6 as well. So r and n are both 6 here. Can I draw the situation better, visualize it? I don't really need to because it's just a word. Did I think about every scenario? I'm going to cover that when I get to the end. So here we're going to have 6, choose 6 in terms of a permutation. You can put this expression into your calculator and it will calculate the answer for you. And so when you do that, you get 720 ways of arranging the letters in the word candle. Did we think about every scenario? We're good to go. 720 ways is our answer. Okay, let's try another one. In how many ways can a group of 4 boys and 3 girls be arranged if no girl is to sit next to each other? Okay, this one's going to be a little tricky, so pay close attention and think critically about it. First question, does order matter? Well, we're arranging the boys and the girls, and so we're assuming they're different people, and so the order of them will matter in this case. So we're going to deal with a permutation. In a second, I'm going to show you why it actually also includes a combination. So I'm going to write P and C here. Next question, how many options are there and how many things are being chosen? To answer that, I'm actually going to draw the situation. So we're assuming we have a group of 4 boys, so I'm going to let them be represented by circles. And then we've got 3 girls. Now, in order for the girls not to sit next to each other, they have to go in the spaces. But keep in mind, they could also go on the outside. So the girls have 5 possible places they could go. So you want to say of 3 girls and there's 5 places they could go, that's actually 5 choose 3. And I did C for combination because you're just shuffling the girls around, and in that case, when the girls, let's say 3 girls were here, here, and here, and then they were flipped around in a different order, it would still be the same location. So that's why I did combination, not permutation. But here's where it gets tricky. I'm also going to include permutations because I'm asking arranging the boys and girls in different order. So I've got 4 boys. Let me just write B here. And I want to ask the question, how many ways are there to arrange those different 4 boys? Well, that's similar to the very first example we did. So that would be 4 factorial. I'm arranging 4 things and I'm not picking 3 out of those 4, but just 4 things, and I'm arranging those things in the positions they are. So that's 4 factorial. And then similarly for the girls, I can arrange the girls in 3 factorial different ways. Now I'm actually going to multiply all 3 of these things together. 3 factorial times 4 factorial times 5 choose 3 factorial. And that's going to give me 1,440 ways. So you really had to think critically about that one. Okay, let's try another one that's a little bit easier. How many 4-digit numbers can be made using each of the following digits only once? Okay, so in this first example, we've got 5 digits to choose from. So here my n equals 5. And we're choosing 4 of them because we're making a 4-digit number. So because order matters because we're constructing a number, I'm going to use permutation. So it's 5 choose 4 in terms of permutation, and that's going to equal 120 different numbers. Okay, and the next one, you're going to have to think about it a little bit because a number cannot actually start with 0, which means for our first choice of the digit, we only have 3 choices. So I'm going to do 3 times, and now from there, I'm going to have, because I've already chosen 1, 3 choices left, and only 3 spots left to fill. So from there, it's going to be n equals 3, r equals 3. So that will be 3, choose 3. That one was a little different from the first one because 0 cannot be the start of a digit, but it can be somewhere else in the number. So this gives us 18 different ways. Okay, last question. There are 8 boys and 5 girls who attend the Senior Mathematics Club. Find out how many ways the teacher can choose a team of 6 students to represent the school in a competition if, part A, there are no gender restrictions. Okay, so we got 8 boys plus 5 girls makes 13 students in total. Now we're only choosing a team of 6. So remember back to the soccer example, when we're choosing a team, order doesn't matter because if we pick the students in different order, they're still the same team. So we're going to do 13 choose 6, and that's going to equal 1,716 different teams. Okay, part B. The restriction is the team has to be made up of 3 girls and 3 boys. Okay, so that composes the whole team of 6. So of the 5 girls, we need to choose 3 of them. And we're going to multiply that by of the 8 boys, we need to choose 3 of them as well. So 5 choose 3 times 8 choose 3, that gives us 560 different teams. And all right, that's it. So go ahead now and try some practice on your own.